Alright, now on to D's and F's in our electron configurations. So, we're going to start off the same way we were doing our last several. We're going to do titanium. According to my periodic table, titanium has 22 electrons that I need to place. So, Aufbau says, got to start at 1. By now, I hope you're beginning to be able to read these configs off the periodic table. Start at 1. 1s, S block, 1s1. Here's my second electrons in the 1s. So 1s2. Gosh darn tall board. Wrap around, 2s. 1 in the 2s. 2 in the 2s. Filled the 2s. 2s2. Across we go. 2s. I'm still on row 2. 2p. 1, 2, 3, 4, 5, 6. Filled up the 2p. Onwards, wrap around, 3s, 3s1, 3s2. Filled up the 3s. Onwards we go. Across the table, I'm still on row 3. This is the p block, 3p. 1, 2, 3, 4, 5, 6. Oops. That's 3p6. Onwards we proceed. 4s, 4s1, 4s2. Filled up my 4s and my writing's crooked. Oh well. Next come the D block. I've only got 2 electrons that I need to place in the D block, but remember Aufbau. Aufbau says that the lowest energy orbitals must be filled first. 3D is a lower energy than 4D. So this row here, even though it's on the 4th row of the periodic table, actually represents 3D. If you're thinking about Bohr's model, that's ring 3. So we're jumping back 1. We fill the 4, then we go back and fill 3D. And we put 2 in the 3D. So this is where the periodic table comes in handy, but you've still got to remember that these drop 1. We are, in fact, filling the 3rd ring of our atom. We go back 1. We'll cover Bohr diagrams in the next one that might help with the understanding. For now, let's keep doing configs. Nickel. There he is, 28 electrons. Think you can handle it? Hopefully you've got a periodic table that you can look at. Start at the beginning. 1s, 2 electrons in the 1s. 2s, 2 electrons in the 2s. 2p can hold 6 electrons. Ran out of space, wrap around to 3s. 2 electrons in the 3s. Straight across the way from the 3s is all to the 3p. 6 electrons in the 3p. Wraps around to 4s. 2 electrons in the 4s. After 4s comes 3d. D's drop 1. How many do we have in that 3d? 1, 2, 3, 4, 5, 6, 7, 8. 3d, 8. Let's draw the spin diagram for this one, just to review. So, 1s, it's an S, 1 room, woo. 2 electrons. 2s, still an S, 2 electrons. 2p, 3 rooms there in my 2p. 1, 2, 3, 4, 5, 6. Remember, 1 in each, then go back and pair. 3s, I ran out of space here. This is why labeling is good. 2 electrons in my 3s. 3p, 1, 2, 3 rooms in my 3p. 1, 2, 3, 4, 5, 6 electrons in my 3p. 4s has 2 electrons. 3d, remember, D's have 5 rooms, 5 different orbitals where I can place my electrons. 1, 2, 3, 4, 5. And just like the P's, you must draw all 5 blanks regardless of whether or not you fill them. Back to the kids on a hot bus thing. 1 electron in each blank, then go back and double. So there's 5, 6, 7, and 8. So I still have 2 unpaireds. There's the spin diagram for nickel. Let's do one more before we call this one done. Neodymium. Neodymium is down here in the F block. This one's going to take a while. Let's see if we can rattle off that config. Starts, as always, at number 1, 1s. 2 electrons go in the 1s. 2s, 2 electrons in the 2s. 2p, 6 electrons in the 2p. 3s, 2. 3p6, in case you lost your place. 3p6, 4s2. After 4s2, we're on to our D's. Remember, D's drop 1. So 4s is followed by 3d. We're going all the way across that D. There are 10 electrons in this 3d row. But as soon as I pass this point here, this block, remember, was our P block. I had nothing weird about levels in my P block. So after 3d, we return to 4p. And we go all the way across the row, 4p6. Now we wrap around to 5s2. After 5s, D block, D's drop 1, 4d10. After I finish the D block, back to the P. Nothing screwy about the P, so back to 5p6. What do I have next? 5s2, 4d10. 5p6. After 5p6, ran out of real estate, off to 6s2. Here we are, 6s2. Now comes the tricky part. Follow the table. This is a D. D's drop 1. 5d1. Follow the table. Big black line brings me down here. F's, if you remember my saying, drop 2. So, even though one would think that perhaps 6F would energetically be next in the order, or perhaps even 5F, no, 4F, in fact, has the lowest energy of the F orbitals. So after 5D1 comes 4F3. So that was a long one. Follow your periodic table when you get to this little hinky part. Here, when you get to 6s, after that comes our 5d here. So follow your table. If you were to go all the way through the F's and then return to the D's, then you can combine those two 5D's into one written spot. But if you don't, follow the table. 5D1, 4F, however many. The F's are tricky, so take your time and look at the periodic table. This is your best friend. If you can use the table, 3/4 of everything you ever wanted to know about any atom is on this table. So don't get frustrated if you're having problems with the D and the F orbitals. They do take quite a bit of practice. So have patience and let me know if you get stuck. Best of luck.